Hello everyone, I am so excited to be making another CMG tutorial for all of you guys. This time we will be looking at CMOST, which is CMG's optimization, history matching, sensitivity analysis, everything sweet. And it's amazing, and we're going to be going and learning how to use it. First of all, of course, we have to thank CMG for giving me use of this software, as well as providing me with a tutorial, which I'll be sharing with you right now. Okay, so let's get started. What are we going to be learning in this tutorial specifically is how to do sensitivity analysis. Let's say that you have a horizontal well, for example, this one over here with hydraulic fractures, and you want to know, well, what are the parameters that are controlling how much oil and how much gas I'll be getting from this field, given the completions and all the rest of the parameters that are present in this model. So you want to do sensitivity analysis. You want to vary the parameters and see which ones are important. And that is what we're going to be doing today. So that's great. What will be the result of if you go and follow this tutorial all the way to the end? You'll be able to see something like this, which says, oh, well, horizontal permeability is important, maybe fracture permeability less so. This is really what I should be caring about. Unfortunately, not too controllable. An important parameter. I can also go and see what are the other important parameters on this list. I can look and then use it to see what are the possible ranges of money that I'll be making. For example, looking at the cumulative gas given all these different models. And this is all very exciting, so I hope you stick around for this tutorial. Well, what are we going to start with? We are going to start with some files that I have put for you guys onto Box. So go and use the link that's in the YouTube description and download this file and put it somewhere like my documents, like I did right over here together with some other folder names like I hate myself. So great. Anyway, so now that we are here, let us open the main .dat file that I was just showing you. Okay, so first of all, I'm going to close it since I already have it open in a different location. And let us open it up. So I'm going to go and take this file name and drag it over to Builder. Great. This is the file that we looked at previously just a second ago. And we can see that there is a horizontal well over here. Now we want to go and be able to change some of these parameters around and see what will be their influence. Okay, so I'm going to go here into Tools, and then I'm going to go and search for this CMOST Master Dataset Creator, clicking on this over here. And I'll be clicking on Reservoir, Grid, or actually Area Properties. I want to see what's going to happen if the porosity changes. So I'm going to go and click on this value over here and then Add. And this will create for me a variable that will be changing in CMOST automatically. Now, gone are the days where you have to change your parameters by hand. So I'm going to click and add here porosity. I'm also interested, like I already showed you, in the permeability, right? So permeability and I and J are the horizontal permeabilities. So I'm just going to go and click here and add. And then this is perm H. Well, guess what? I is also in the horizontal direction. So I don't want to make two redundant parameters, so I'm going to click right over here. Oh, and if it works, it should be able to let me give this a new name. Ah, finally. I'm also going to call this perm H. Now, this is the vertical, this is in IJK, yes. This is in the vertical direction, so I'm going to add this over here, and then I'm going to call this perm B. Perfect. So we now have horizontal, vertical permeability. Those are things I care about. Also, rock compressibility, pretty interesting. Let's add that in there. And add, and then rock compressibility. Perfecto. Now let's move on this list. In hydraulic fractures, of course, this is, we're looking at an unconventional situation. I'm interested in what the influence of the hydraulic fracture properties are. So let us go look at the half length. How far do the fractures extend from the wellbore? How does that influence my design? Then also let's look at the fracture permeability, which I'll put right over here. And the number of layers up. Okay, fracture layer up, fracture layers up, fracture layers down. And very nice. Okay, what else is interesting here? Well, I'm going to go on from here. Let's say I'm also interested in the relative permeability values. So you can go over here under builder keywords. I'm going to go to rock type 1 and then show data. And I want to look at these relative permeability tables. Never trust them. Want to see what happens when they change. Okay, so I'm going to be adding the parameters. And you can see here, so that's KRO, OCW. Okay, so that was that. Good. And this is the relative permeability of oil relative to content water. And we can add this one over here. So that's KRGCL. KRGCL. Perfect. Okay, let's go on to the next one. Okay, let's add this SORG. Guys, we're almost there. Just follow along and you will find it will all be okay. Okay, SJ critical. Another 2. Add this over here. And as you can see, how do I know what parameter this is? It says it right over here. So I'm going to click on that and then add and oil relative to the gas. And last one, I'm going to add over here. Great. Excellent. Okay, I think that's basically all I want to look at, right? No worries if I forgot something. I'll be able to come back to this later. Not the end of the world. So I'm going to click on OK over here. Current was modified. You want to save? Yes, of course. Not working for no reason. Do you want to close the window? Some CMOS patterns will be lost. The window is closed. Do you want to close the window? Yes. Okay, well, great. Let us move on. Now, we have magically, I believe, should have created another file over here. So let's refresh this. And ta-da! We have tight oil base.cmm. Perfecto. Okay, so now what we're going to do is we're going to open the CMOST application. I'm going to go and double click right over here, and the amazing CMOST is going to open. Perfect. Now I'm going to go and say I want a new project. I'm going to call this project tight oil. Okay, and what is going to be the base data set? Remember, we downloaded this folder over here, and we from Box, and we're going to go and use this base data set that we also just modified a little bit by making this CMM file. Okay, so we just did that, and we're going to go and create a new study, and we're going to call this tight oil sensitivity analysis. Okay, now what is our base data set? Guys, no surprise, this is just the one that we made. So we're going to go double click on it over here, and we're going to make this a sensitivity analysis type of study, because that's what we're doing. Okay, and it's making the study for us. Perfect. Okay, let's go in and look what's going on. So on the left side over here, we have several different items that we're going to go through setting up our project one by one. Okay, so let us go to general properties. So you can see here there's this default CMM file that it made for us, but actually we have made one already, so we want to get that one to use. Remember, we made tight oil base.cmm. So would you like to copy it? Yes, let's put it there. And now let's go to base dataset. That looks pretty good. Also, for a future tutorial, we're going to already import a field history file data that we're going to later use for history matching. So we're going to go and double click on these two things and click on open. Perfect. Okay, now let's go on to fundamental data. What is fundamental data? Well, actually, we're going to skip over that at the moment and go to the parameters first. Sorry, guys. Okay, we're going to go and click here on import, and that is going to import all those variables that we just laboriously defined previously. So now the importing operation was successful, and look at all of these files. Now let us pretend for a moment that we have forgotten a variable. It's not the end of the world. All I will do is I will go here to Builder, and it will open it up, and it will bring me to the same situation. Just for the sake of it, let us go and import one more parameter, just to imagine that we forgot it. I really wanted to know about I don't even know what I want to know about pinch out array, for example. I'm going to click on add here and pinch out array constant. Okay. Save changes. Do you want to override it? Sure. Okay. And let's go and refresh that import, and we should have had another parameter come out over here. Now we're not actually interested in that, so we're going to delete it. But I was just going to show you, not the end of the world if you forgot something. Okay, so now let's take a little bit of a closer look at what this panel is. So we have the name of the parameter, and then over here we have a picture of the prior distribution of the parameter. That is, what are the possible values that this parameter could have? And we can see here by default, if the default value is 2, it's going to go and do 25% up and down in that, so it's going to set here a limit of 1.5 to 2.5. And this is by default a uniform distribution, meaning it could be equally likely be any value between 1.5 and 2.5. If you have some more, let's say you think, well, I think it's most likely 2, and it's a little less likely that's anything on the sides, you could also use a different distribution, as in the normal distribution. But we're going to keep it at the default, being a uniform, and we're going to go and set the ranges. Now, we're looking here at the number of fracture layers down that the hydraulic fractures extend. Let's say that it should be somewhere between 0 and 4 layers that it extends downwards. Okay, this is actually not a continuous variable, it's a discrete variable. So I'm going to go click here, discrete integer. Then I am going to generate some values from 0 to 4. Now, for those of you who want to know, that is n plus 1 actual values, right? Because you have including 0. So that's 5 values generating for us. Okay, so we have 0 to 4, 5 values, are equally likely to be chosen for the sensitivity analysis. What the sensitivity analysis does is it chooses random values from all of these parameters and then see how each one of these influences a specific objective value that we are interested in. For example, how much oil is being produced, or in this case, how much gas. Okay, so we're going to go and move on. Same thing goes for fracture layers down. We're going to make this a discrete integer, and we're going to generate some values. Let's say you can only go to 3 this time. That's going to be 4 values. I'm going to generate that. Ta-da! I have my prior distribution. Let's go to half length. Now this is a continuous, and the range it's giving me is a bit small. I think it can go even lower than 30, and then I think maybe it can go even a bit higher, 20 to 90, something like that, for the half length. And okay, perm H. So I've already put it in over here. I think the lower limit of the horizontal permeability is 0.01 to 0.4. Great. However, if we look at the permeability in the vertical direction, you think to yourself, oh, these things are actually correlated. Usually if you have, low permeability in the horizontal direction, you're probably going to have a low permeability in the vertical direction and possibly even lower than that. So we're going to go and define these by a KV-KH ratio. So we're going to put a formula here, and then we're going to say, and I already have that in here, that the permeability is permeability of H times a ratio. But what is this ratio? Well, we can go and define a new variable. I'm going to call it the KV, the vertical permeability relative to the horizontal permeability, so KV-KH ratio. And by default, we're going to give this a value of 0.25, and we're going to say that this ranges from 0.05 to 0.5, meaning that the vertical permeability can be up to half of what the horizontal permeability is. because the horizontal permeability tends to be higher. Okay, great. Fracture permeability, I've already put in here some values, so I won't have to type or talk. And we have porosity, a range of values, and then we have a range of values for all the rest of these numbers in the relative permeability tables. So I hope you have good eyesight. I'm just running through these quickly. Take a look, pause, and then update in your model these values. Okay, perfect. Great. So now we are done with looking at the parameterization. So let us move on and take a look at the objective functions. And we can go and look, what do we actually care about? So we're going to care about three things. So I'm opening 3 different variables that we want to look at. So that's the cumulative oil, okay? So I'm looking at the one well that I have in this model, and I'm going to go and choose cumulative oil. And I'm also interested in the cumulative gas. And I'm going to go choose the origin name and the cumulative gas. And I'm also interested in the oil-gas ratio. Okay. I'm going to go and search for it. And I actually made a little mistake here, guys. So, gas-oil ratio. Okay, perfecto. We got this going. So let us move on. These are what we call the objective function, right? This is what we're interested in looking at. We want to know how the parameters that we just mentioned here, for example, the permeability, the relative permeability values, how do those influence our objective, which is to make a profit, which is dependent on the cumulative oil and the cumulative gas that you're going to get over time from your fields. Okay, so now that we are done with that, let us move on. And I've actually forgotten one thing. We moved a bit too quickly, and that is the pre-simulation commands. And what this does is it goes and says, oh, I need to run a builder to go and do some processing of my input parameters before going and doing the sensitivity analysis. So that's right over here, and this will make builder go and create a lot of data files for each one of our parameter combinations that the CMOST will choose. Okay, so let's move on to the control center. Okay, well, we already see that it's filled in with some values, some status of runs that's planning to do, number of experiments that's planning to run. Let's go and specify a little more carefully the engine settings. So you see it's doing a sensitivity analysis. It's going to create a response surface. That means it's going to make a proxy of what is the cumulative oil based on the parameters, kind of using data science. So you see values that are changing in the parameters, you see the output, and then you can go and create a surface which will go and approximate your output based on your parameters without even doing a simulation. So that's the name of the engine, the number of experiments. Actually, we're going to keep all of these at default. And let's go on to simulation settings. So, CMG is now launching a lot of these new cloud servers, which is amazing. Meaning if you don't even have enough computation power, you can just buy some time online on the cloud. If you don't have your own local machine, that's very powerful. So I'm going to go and choose here that I want to use the local machine because I don't have this cloud server. I'm going to say the number of cores I want per job is 1. I'm going to say that the max concurrent jobs that I want is going to be 4. And the max runtime, I don't want this thing to go overboard. Let's make that 1. Okay. Now let's go to the experiments table. And it says here, waiting to be reprocessed. And why is that? Because it's missing a value of some sort. So let's go here and we say resolve reuse pending. And it's missing the value of a KV/KH ratio. Remember, we defined that on our own. We just made that up. So for that default run, was 0.25. So I'm just going to leave it there at 0.25 and click on OK. And I think it should be reprocessing at this point. Perfect. We can see that the little error sign has disappeared from here. As a matter of fact, it's disappeared from all of these steps in the process. So that means I think we're basically ready to go. So let's go to the control center. Actually, first, we didn't do this the whole time. You guys should always do this, and that is click save. And you should click save throughout this whole tutorial, okay? Let's click go. Oh my God, it's about to happen. Oh no. We have an error here. Parameter pinch-out array is used in CMM file, but it has not been defined in the study input. Seems like I deleted it, but it did not get itself deleted from the CMM file. Okay. Let's go here. And we don't see it. So here, this is actually getting to be a slightly more complicated tutorial than one would like. So I'm going to go here and click on cedit. And cedit is a text editor for CMM files. And we're going to go and search in here for this pinch out. And we're going to see here something interesting. So how does this, wasn't planned part of the tutorial, but let's think about how this works with the CMM. What does the CMM file do? Usually you have here permeability in the K direction, constant, and then a number, like 0.06. What the CMM file does is it goes and it says, okay, that number that was here, I'm going to be varying it around. And you can see here little tags, CMOST, CMOST. I'm going to call this parameter permv, and I'll be changing it. Every time I'm going to make a new simulation run, I'm going to be changing this parameter according to what we defined in the table. And now it created an additional one here for pinch-out array. Now, I think that we usually would like this value to be, all the values to be 1 all the time. So we're going to change that to 1. And we actually could have seen that before, that the default was 1. So no harm done. We just learned something new. We just took out this CMOST parameter that was varying. Now we're going to click save. And that was an exciting detour, guys. We learned a lot. Also, you could use that to, I'll go back to there actually, since that's interesting. Another way of going and creating parameters, and this is important. Let's say you wanted to vary, let's see, what would you want to vary? The date, for example, or I don't know what else, or the reference depth that you have. Let's say you want to vary the reference depth. You could go here and say create parameter. Parameter name, reference depth, default value 314, and we'll create that here. And then if you click on import, it will pop up over here. So that's exciting. And we're going to undo this. And we don't want to save the changes. Okay, but I think right now we should be good to go, finally. So let's go to Control Center and pray to God that there are no more errors. That was just unexpected. And click on OK. And it seems like things are running. We just had a fun detour because of creating a fake variable. Great. So it's starting to validate the input data. Let's hold on tight here a little bit longer just to see that everything is running nicely. Great. It's already showing here, as you guys can see, that there's one normally terminated simulation. That's probably the base one that you gave it in the beginning. And now it's creating a new, starting an engine, starting this pre-simulation command to go and create these these .dat files that will be the input models. So it's creating them based on the parameters that we described, and then it's going to send it to run. So it says start pre-simulation, and it's submitted to the local machine. We can also follow that over here in the experiments table as it's moving along. You can see running, creating data set created. So this is great. Now it's going to run a lot of these. So of course, we're not going to keep the video running while it's making all this, but we are going to pretend this has all happened already. And it can go pretty fast because this is a pretty simple model. So we are going to pause and then go and take a look at the results when they are finished. Okay, ladies, so we just finished running all of our experiments, and this is great. Everything is green, normal termination, complete, perfect. Let's go and take a look now at our results. So we're going to go into these to this final panel here in results and analysis. Okay, and what can we see here? Well, let's see all of the parameters that have been chosen. And we can see here that, like we expect, there's a random distribution of the number of layers down that each fracture has, and so on and so forth. Uniform random distribution, and it's looking gorgeous. It will even look prettier with these nice histograms. It's always good to see things and a lot of different visuals. You know, it's a random process also, so it's not always, should theoretically be flat on top, but because we didn't take an infinite number of samples, that is not the case. Perfect. Okay, so let's go and start looking at the time series. And the time series here is going to show us our objective functions of all the different simulations. And not only that, we can also see here the truth of what has been measured in the field. So we can see that some of these subsurface parameters and hydraulic parameter values have actually led to something that looks quite similar to the measured data in the field, and that will be used in the next tutorial regarding history matching. Just giving you some notes, and let's go look here. We can see the time over here, and the cumulative oil, and the cumulative gas, and the gas-oil ratio, and that's perfect. Let us go and continue onwards to this objective function panel right over here. And we can look at the run progress, how the objective function values change with each experiment. There's our 5-star one. And let's go here. You can see some histograms, which is, of course, always important, right? Because you want to get your P10, 50, P90 for what, assuming we didn't already have this, field observations, you might be interested in knowing, well, what's P10, 50, and you would get that from the histograms. And let's go and look at some crossplots. So what a crossplot does, it takes our objective function, in this case cumulative oil, and we can plot it against all the parameters. And then we can look here and we can try to sphere some trends, like when you have a lot of layers down, does that increase the oil? It's not very clear to see. It's a bit difficult. This trend here. Here's a clear trend. As the permeability in the H direction increases, then we have more oil. That's great. Good to know. This looks like a nice and clear trend. Another clear trend. Less clear, less clear, less clear, and so on. Okay, you can do the same thing with oil and with gas. If you want to look at how all the parameters seem to have influenced your target objective of cumulative gas, you could go and scroll around over here. Okay, so now let's go to another interesting one, and that is the proxy analysis. And let's look at cumulative gas. Okay, and we can do some model QC. And what does this mean? So, as you recall, I explained previously that we are creating a proxy surface function, right? And what that means is it's creating a pseudo simulator, which does not do any finite element, nothing, finite difference. It just goes and uses the data and some relationships to get to your prediction. So it takes all your input parameters and outputs the simulated cumulative gas based on just some learned relationships. And here we can see the training experiments, what it's used to go and tweak the parameters for the different models. And here we see some verification. And we can see that it's not bad. It's pretty close to this 45-degree line, which shows, if everything lied on this line, it would mean that the model, the proxy model is perfect. So it's looking pretty good. So that's our model QC, or quality assurance. Now we can look here at statistics. We see that the R squared is pretty good, 0.9. And another thing to look at is, let's look at these different parameters here that it's using. And the parameters that it's using means that these parameters are somewhat important if it's choosing to use them in the model. And you can also look at the probability of greater than absolute value of t. And if this value is very low, that means that this parameter is super important and influential on the model. And we can see that they're all pretty important. So we want to know, though, what are the most important parameters? So we can see right here in this effect estimates that an increase in the parameter of permeability in the horizontal direction can cause a fairly large increase in your cumulative gas. On the other hand, the square of that, I guess there's too much permeability, can cause a lowering of the cumulative gas. And you can look at that. When you increase the fracture permeability, you get more gas. Increase the KV-KH ratio, more gas, and so on. And these are our effect estimates. Then we have this Morse analysis here, which will tell us, okay, again, what are some important parameters? And we again see here, and we saw that also in the data of just by visual inspection, that permeability in the horizontal direction is super important. And we can see also the other absolute elementary effects of the different parameters. And this kind of gives us an idea as how much influence does interactions of these parameters have on the outcome. And you can see that the only one that has large influence on the interactions is the horizontal permeability. Going to look at the Sobel analysis. Again, we are seeing what we saw in all the rest of them. Horizontal permeability is important, the fracture permeability is important, the number of layers down important, this ratio is important, and so on. That's great. So now we know this, and we know that horizontal permeability is important, but we can also work, even though we can't change this, at least we can work on trying to increase the fracture permeability, maybe using proppant, something like that. Okay, now let's go to the last thing for this tutorial, and that is looking at the Proxy dashboard. That's over here in the control center. So we're going to go and generate the proxy by clicking on each one of these proxy model generation buttons. And there we go. There we go. Okay, and what do we see here is we're going to go to fundamental data series plots, and we want to plot all of our data, and we're going to put it here in let's say 2 in the vertical. These are all of our data points. What we see here is our field history, and what we see here is the prediction for the parameters from experiment ID 1. These are our parameters, and what the results of the simulation are. So that should be here somewhere in black. Well, let us clean this up a bit so that we can see better. There it is. So if we use these parameters, we get this prediction, which is a bit off from the measured field history. Okay? And we can also use a model which will go and predict for us, like a proxy model, what are the values. And we see that this polynomial regression isn't doing that good on predicting this RBF neural network, though. The radial basis function is looking pretty good. It's right on. So let's look at that one as a good predictor. And yeah, not so good. Okay. Now let's look at the what-if scenario using the RBF. And what is a what-if scenario? I go on and tell myself, what if the permeability in H was different? What would change? Oh, okay, so this is our prediction from the what-if scenario. And we see that if I went and increased the permeability in the horizontal direction, that goes up. And if I decreased it, that goes down. And wow, I can just by changing this permeability H, I can go and do some kind of like rough history matching here, right? I can just change around the parameters until I see which are the parameters that created this field history. I'm a little bit off over there. Maybe if I change around this one, okay, things are moving up and down, and so on. You can go and you can play around and try to do your by hand history matching. Also, you can get a little bit of insight about the sensitivity analysis by doing this, right? If I go and I change this and here to here, it's not going crazy, But if I change like we said before, the sensitive parameter over here, I'm moving a little bit to the sides, and it's going woo, all the way up and all the way down. So it's a very sensitive parameter. That's it, guys. We are done. Well, I'll be following this up with another tutorial on optimization. So stay tuned. And that's it. I hope you have a wonderful time today, tomorrow, all the time.